Hello, and welcome to our lesson on quantitative risk assessment. This segment will cover quantitative risk analysis techniques. Quantitative analysis techniques are powerful tools in project risk management, offering a structured and systematic approach to assessing risks and uncertainties. By assigning numerical values to probabilities, impacts, and uncertainties, these techniques provide project teams with quantitative insights into the potential outcomes of various risk scenarios. This section will explore the methodologies and tools essential for conducting rigorous quantitative risk analysis, empowering you to make informed decisions and develop robust risk mitigation strategies. Throughout this journey, we will explore diverse quantitative techniques tailored to address different aspects of project risk. Our exploration will include Monte Carlo simulation. For instance, enables project managers to simulate thousands of possible project outcomes by randomly selecting input values from probability distributions. This iterative process provides a realistic depiction of potential project scenarios, empowering project teams to identify and mitigate risks effectively. Sensitivity analysis, on the other hand, helps project managers understand the impact of variations in critical variables on project outcomes. By systematically varying input parameters and observing their effects on project objectives, project teams can prioritize risk response efforts and allocate resources strategically. Influence diagrams illustrate complex project scenarios, illustrating the relationships and dependencies among various project elements. By visually mapping out these relationships, project teams can identify critical pathways and potential intervention points to mitigate risks and optimize project performance. Expected monetary value is a statistical tool for quantifying risks and determining appropriate contingency reserves. By calculating the expected value of different risk outcomes, project teams can allocate resources effectively and develop proactive risk mitigation strategies to address uncertainties. Decision trees provide a structured framework for evaluating alternative courses of action and assessing their potential outcomes. By analyzing decision trees, project teams can identify optimal risk management and resource allocation strategies, maximizing the likelihood of project success. Lastly, probability distribution enables project teams to visualize the likelihood of various events occurring and their potential impacts on project objectives. By understanding the probability density function associated with different outcomes, project teams can assess the overall risk exposure and develop mitigation plans accordingly. Each technique offers unique advantages and insights, allowing project teams to comprehensively understand the risk landscape and make proactive decisions to enhance project resilience and success. By navigating through these quantitative analysis techniques, project teams can harness the power of numbers to enhance project resilience and success. By gaining insights into the project's risk landscape and developing proactive risk management strategies, project teams can confidently navigate uncertainties and achieve project objectives. One of the most widely used simulation methods is Monte Carlo analysis, renowned for providing comprehensive insights into project risk and uncertainty. During the Monte Carlo analysis, project managers employed specialized software to iterate the quantitative risk analysis model thousands of times. Each iteration randomly selects input values, such as cost or duration estimates, from probability distributions representing project uncertainties. Through this iterative process, the simulation generates a range of possible project outcomes, such as project end date or cost at completion. For cost risk analysis, Monte Carlo simulation utilizes project cost estimates as input values, while for schedule risk analysis, it relies on the schedule network diagram and duration estimates. Integrated cost schedule risk analysis combines both inputs to offer a holistic view of project risk. The outputs of the Monte Carlo simulation provide valuable insights into the range of possible project outcomes. This includes histograms illustrating the frequency of particular outcomes across iterations and cumulative probability distributions, S-curves, depicting the likelihood of achieving specific outcomes or less, and offering stakeholders a visual representation of project risk exposure. Moreover, Monte Carlo analysis enables criticality analysis, a technique to identify risk model elements that impact the project's critical musical path. Project teams can prioritize risk response planning efforts by calculating a criticality index of each component, representing its frequency on the critical path during simulations. Elements with higher criticality indices receive greater attention, allowing project managers to focus on mitigating risks that pose the most significant threats to overall schedule performance. In essence, simulation through Monte Carlo analysis empowers project teams to navigate uncertainties effectively, make informed decisions, and develop robust risk management strategies. By simulating various scenarios and assessing their impact on project outcomes, organizations can enhance their ability to achieve project success amidst complex and dynamic environments. This is the end of this segment of our lesson. In the next segment, we shall continue discussing quantitative risk analysis techniques. This course is presented to you by South Europe College. Thank you for listening and see you on our next segment.